The Indian Space Research Organisation, following a landmark 2023, will ring in the new year with the launch of the PSLV C-58 X-ray polarimeter satellite or XPOSat mission on January 1. Whenever there is a news on ISRO coming, we often hear about PSLV and GSLV. So what does it really mean? Let's find out in this class. Both PSLV, the Polar Satellite Launch Vehicle, and GSLV, Geosynchronous Satellite Launch Vehicle, are the satellite launch vehicle rockets developed by ISRO. PSLV is designed mainly to deliver the Earth observation or remote sensing satellites with a liftoff mass up to about 1750 kilo to sun-synchronous circular polar orbits of 600 to 900 kilometer altitude. The remote sensing satellites orbit the Earth from pole to pole at about 98-degree orbital plane inclination. An orbit is called sun-synchronous when the angle between the line joining the center of the Earth and the satellite and the Sun is constant throughout the orbit. Due to their sun-synchronism nature, these orbits are also referred to as low Earth orbit or LEO, which enables the onboard camera to take images of the Earth under the same sun illumination conditions during each of the repeated visits the satellite makes over the same area on the ground, thus making the satellite useful for Earth resource monitoring. Apart from launching the remote sensing satellites to sun-synchronous polar orbits, the PSLV is also used to launch the satellites of lower liftoff mass up to almost 1400 kilos to the elliptical geosynchronous transfer orbit or GTO. PSLV is a four-stage launch vehicle with the first and the third stage using solid rocket motors and the second and fourth stages using liquid rocket engines. It also uses strap-on motors to augment the thrust provided by the first stage. And depending upon the number of these strap-on boosters, the PSLV is again classified into various versions like core-alone versions like PSLV-CA, PSLV-G or PSLV-XL variants. So this was all about PSLV. What else do you know about the GSLV? The GSLV is designed mainly to deliver the communication satellites to the highly elliptical geosynchronous transfer orbit or GTO. The satellite in GTO is further raised to its final destination, geosynchronous Earth orbit of about 36,000 km altitude and 0-degree inclination on equatorial plane by firing its built-on board engines. Due to their geosynchronous nature, the satellites in this orbits appear to remain permanently fixed in the position in the sky as viewed from particular location on Earth, thus avoiding the need for tracking around antenna and hence are useful for the communication application. So the two versions of GSLV are being developed by ISRO. The first GSLV Mk2 has the capability to launch satellites of liftoff mass up to 2,500 kilos to the GTO and satellites up to 5,000 kilo liftoff mass to the LEO. GSLV Mk2 is a three-staged vehicle with first stage using solid rocket motor, second stage using liquid fuel and the third stage using cryogenic upper stage using cryogenic engine. So this was all about PSLV and the GSLV. So it's important that you also know about the various other uses, like the first rocket developed by ISRO was simply called SLV or Satellite Launch Vehicle. It was followed by the ASLV, which was Augmented Satellite Launch Vehicle. SLV and ASLV both could carry small satellites weighing up to 150 kilo to lower Earth orbits. ASLV operated till the early 1990s before PSLV came to the scene. And also, what is the concept of SSLV? The SSLV's target at rising global demand for the launch of small and micro satellites. SSLV is meant to offer cost-effective launch services for satellites up to 500 kilos. It is supposed to carry an indigenous Earth observation satellite, EOS-3, into space. The future rockets are meant to be reusable. Only a small part of the rocket would be destroyed during the mission, so now the future rockets. The bulk of the future rockets would re-enter the Earth's atmosphere and land very much like an aeroplane and can be used in the future missions also. Reusable rockets would cut down on cost and energy and also reduce space debris, which is becoming a serious problem because of the large number of launches. Fully reusable rockets are still to be developed, but partially reusable launch vehicles are already in use. ISRO has already developed a reusable rocket called RLVTD, the Reusable Launch Vehicle Technology Demonstrator, which has had a very successful flight in 2016.